So in the previous section, we talked about a few ways of actually importing data into your cluster in real time in streams of data that are just flowing continuously. So why would you process that data in a batch manner if it's coming in all the time? Why bother kicking off these daily jobs to analyze that data when you could just analyze it as it's coming in? Well, that's what we're going to talk about in the coming section, a couple of ways of actually processing that data in real time as it's received. We'll talk about a couple of ways of doing that, like Spark Streaming and Apache Storm, and figure out how you can not only stream data in real time into your cluster, but also process it in real time as it's received. So let's see how that works. So let's talk about one way of processing data in real time as it comes in. That's Spark Streaming. So what's the point of something like Spark Streaming? Well, like we said, big data never really stops flowing. If you have data flowing in from user activity that's being captured in your web server logs, that's just going to keep coming in 24/7. If you have data coming in from some big Internet of Things deployment from various sensors, that sensor data never stops coming either. So why would you limit yourself to processing data on a batch basis? And there are scalability concerns there. What happens if that batch gets too big to handle when you can actually process the data in real time as it comes in? So that's what Spark Streaming and streaming in general is all about. So at a high level, here's how Spark Streaming works. Basically, you have a bunch of data streams coming in. Maybe this is coming in from Flume or Kafka or something else, just listening to sockets on a TCP connection on a fleet of servers, who knows? But your Spark cluster might have a bunch of receivers out there that are receiving this data spread out across your cluster for Spark. And what Spark Streaming does is it discretizes that information coming in that stream into little chunks. So you can give it a batch increment time of, say, 1 second or 2 seconds or whatever you think is appropriate, and it will split that data up into little 1 second or whatever increment you specify chunks into individual RDDs. So each RDD within that stream of data will contain some discretized chunk of data received over some small time period. And from there, you can transform that data and process it like you would any other stream RDD, or non-stream RDD rather, in Spark across your Spark cluster. So something about Spark Streaming is it's not really real time because it's really dealing in what we call micro batches. So it's splitting up your data into these little RDDs that then get managed together as part of a larger structure. So technically speaking, it's not real time, but from a practical standpoint, you're breaking data down usually into like 1 second chunks. So it may as well be real time. And of course, the beauty of it is that all this work can be distributed, so the receiving of that data and the processing of all those little chunks of RDDs can happen in parallel across different worker nodes across your Spark cluster or your Hadoop cluster. Now, the abstraction on top of all those chunks of RDDs is called a D-stream, for discretized stream. So the D-stream object is what's responsible for generating all those RDDs at each batch interval, and it can produce output at the end of each batch interval as well. So by applying a transform or an action to a D stream, you're saying, as each batch is received, perform this operation on the D stream forever. So a Spark Streaming job is a little bit different from a regular Spark job in that you perform operations on a D stream, and that gets applied every time new data is received in a batch. And then you just kick it off at the end of the script and say, go run this forever until I say to stop. So that's a little bit different from a batch processing in Spark where you just say, I want to get an RDD that represents everything in my entire cluster for whatever I looked up, processes it all at once, and then I'm done. With D streams, you can still transform and map things and perform actions just like you would on an RDD, but that gets applied continuously over time as new batches of information get received. If you do need to get access to the underlying RDDs in a D stream, you can get those too. So sometimes you want to do something on an RDD that you can't do in a D stream. That is still possible. And on a D stream, you can do all the usual suspects. You can apply maps, flat maps, filters. You can do reduction, reduce by key operations as well. So for all the most powerful things you can do on a Spark RDD, you can also do on a D stream in Spark Streaming. You can also maintain stateful data, so you're not limited to just processing these little micro batches of information as they come in. You can also maintain longer-lived state that persists beyond a certain batch interval. So I can keep running totals on stuff. I can break those running totals down by certain keys if I want. I can aggregate session data and web activity and maintain sessions over time. So you're not limited to dealing with these little micro batches. You can actually maintain state over a period of time with a D stream on Spark Streaming as well. How does that work? It works with a technique called windowing. And windowed transformations are what allow you to compute results over a longer time period than your batch interval. So let's take an example. Let's say you want to analyze top sellers that are received from the past hour by looking at activity data that's coming from your e-commerce website from a bunch of different web servers. So I could set up a batch interval of 1 second if I wanted to make sure that data gets processed very quickly, but I could maintain a window of an hour. So by doing that, I would have this sliding window of 1 hour as time goes on, and whenever I want to, I can say, okay, take a snapshot of all the data from the past hour, and sum up all the batches that were received within that window interval. So Spark Streaming can keep a copy of all that information throughout that window of time and then aggregate across that entire window of time on a periodic basis. So as time goes on, that window will slide forward. So if I say I want to compute top sellers from the past hour, it will look at the past hour from now, going back from now, and compute that as time goes on. So when we talk about windowing, there's 3 different intervals we need to think about. So let's understand those. Batch interval is what we've talked about from the beginning. That's basically how often we capture data into a dstream as a discrete RDD. So how often are we sampling the data that's coming in? The slide interval is how often we compute our window transformation. So, in the example of saying I want to compute top sellers for the past hour, maybe I would want to actually recompute that every half hour. And that would be the slide interval. So if I wanted to compute the best sellers over the past hour every half hour, the batch interval might be something like 1 second, but the slide interval would be a half an hour, and then the window interval would be the 1 hour time that I go back in to analyze the data. Okay? Makes sense? So batch interval is how often I'm sampling the data and processing it. Slide interval is how often I'm computing my window transformation, and the window interval is how far back in time I go to compute that windowed transformation. Let's look at a little example here to make it sink in a little bit more. So let's say that I have a 1 second batch interval, and I have a window interval of 3 seconds and a slide interval of 2 seconds. This is what this would look like. So every 1 second, I would be generating a batch of information into RDDs inside my dstream. And then every 2 seconds, I would compute a result because that's my slide interval. So every 2 seconds, we say compute result, compute result, compute result. And the window interval says when I compute that result, how far back in time do I go? So a window interval of 3 seconds means I want to go back to the previous 3 batches and compute the results over that window of time. And so at this example at the end, my slide interval was hit. I compute a result that says go back to the previous 3 seconds worth of information, and it would compute some result over those 3 RDDs. Same with this one here. We'll go back to those 3. In this case, however, we don't have 3 seconds yet because this stream just started. So in that case, it will just take whatever information it has. In this case, the first 2 batches, because that's all that's available. The third one doesn't exist yet, but that's okay. It can handle it. Make sense? I'm going a little bit fast here. Spark Streaming is a very complicated topic. There's a lot of features we could talk about. In fact, I have a whole course on it. So we're kind of rushing through the high-level picture of Spark Streaming here just to give you an idea of how it works and what some of its capabilities are. How does Windows transformations look like in code? Well, in Python, it would look like this. So in addition to a Spark context, in Spark Streaming, you set up a streaming context as well. So you just create a streaming context based on your Spark context, and that second parameter is your batch interval. So this would mean I want to create a streaming context based on a given Spark context with a batch interval of 1. Okay? And once you have a streaming context, you can do things like call reduce by key and window on it. So let's say that I have some sort of dstream I created off of that dstream context. I could call reduce by key and window on that dstream like this. So the arguments that you give this would be a lambda function. This is basically how do I combine two things together within that window. So this is saying given 2 values x and y, I would combine them by just adding them together, x plus y. Then you have to pass in a function for how you actually remove items from your computation. So in this case, it would be subtracting them from each other. And then we specify the slide interval, the window interval, which is 300 or 5 minutes in this case, and a slide interval of 1 second. So this little sample here is saying I want to count things up, in the usual manner of just adding and subtracting things mathematically over the past 5 minutes, and I want to compute that every 1 second, and the batch interval is also 1 second. Okay, so what this code would do would be every 1 second, go back 5 minutes, count something up that's in that dstream and hashtag key values and print out the result. All right, one more thing to talk about, structured streaming. So this is all kind of the old school way of how Spark Streaming worked, but we're in this transition period where we're moving toward a new paradigm in Spark streaming called structured streaming. And as of this recording, Spark 2.1 is what's available. And within Hortonworks, only Spark 2.0 is available. But in both, structured streaming is available as an experimental alpha release. But it is where the future is headed, so we should talk about it. So we already talked about how Spark is moving toward a dataset API based on data frames as opposed to just using RDDs directly. And in a similar spirit, structured streaming uses datasets instead of dstreams as its primary API. So imagine a data frame that never ends. The idea behind structured streaming is that instead of dealing with individual RDDs and dstreams, instead you just have a data frame that contains some sort of structured data in a tabular format, and this table just keeps getting new rows appended to it forever, basically. So from an API standpoint, it looks just like dealing with another dstream. The only difference is that data is being added continuously, and there are new window operations you can perform on that data frame. So this has a lot of advantages to it. For one thing, the streaming version of a code, it looks a lot like the non-streaming version. The way that you would write your code is not much different. So it's very easy to move from a batch analysis script to something that actually handles streaming data in real time. And there are some performance advantages to using data sets in general that are glossed over here. The other thing too, the big thing is that the rest of Spark is also moving toward data sets API. So for example, Spark's machine learning library, MLlib, is also moving toward a dataset API. So you can imagine a world where we have a structured streaming dataset that just receives new data all the time, and we can just pass that right into the machine learning library to do interesting data analysis on it. So that opens up some pretty exciting possibilities where I can actually do real machine learning and data mining on data as it's received in real time. So that's kind of where things are heading. Now, from a code standpoint, it's pretty exciting, actually. So let's say I wanted to write some code that would actually monitor an S3 bucket for new log data and group up how many times a certain action is received over a 1-hour window and then write the results out to a database somewhere. You could actually do that with 2 lines of code using structured streaming. So you can see it's a very powerful concept and a very terse syntax for doing something like that. This is Scala code, by the way. Scala is a bit more popular when dealing with Spark, but we'll stick with Python for now. It's a little bit easier while you're learning. So with that, let's play. Like I said, structured streaming is still an experimental thing, so we're going to stick with the existing dstream API for now. And what we're going to do with our little hands-on example is use Flume, like we did in the previous section, to monitor a directory for new logs that are dropped into it. But this time, instead of connecting Flume to a sink that actually writes that data into HDFS, I'm going to tell Flume just write it out in Avro format to a specific port on our local host. And then I can set up Spark Streaming to listen to that port and just receive data in the Avro format from Flume automatically. And what we'll do with Spark Streaming is just count up how many times each unique URL in my weblogs appears over some window of time. 5 minutes, I think we'll do. So structurally, this is what it looks like, what we're doing. We have a bucket of logs that are sitting somewhere in a directory. We set up a Flume spool directory to monitor new files that are thrown into that log directory. Those go through a memory channel to an Avro sync, and that Avro sync just writes data out to a port in a very concise format. And then our Spark Streaming script will listen to that port through Avro and perform the actual transformations on that to analyze over time what are the frequencies with which each URL is encountered within that log over the past 5 minutes. We will then write that output out just to the console to keep it simple so we can see what's going on. But you could just as easily write out to HDFS or some database or whatever you want as well, just like you could with any Spark job, right? And you might say to yourself, this is an awfully complicated arrangement for doing something relatively simple. But remember, Spark Streaming itself is running on its own cluster. You can scale that as much as you want to handle the processing of the data. Flume is also spread out on a cluster as well. So the power of this idea is that you can actually independently scale the communication, the processing, the pushing around of all this data from the processing of that data independently. So this is a very scalable and robust architecture, although it may appear complicated at first sight. So let's dive in and give it a go.